So I want us to discuss chapter 4, which is this part. So hopefully you all know now how the flags work. Let me just try to explain them. I'm gonna study. So we've got four types of flags, right? We've got the zero flag, the sign flag, the carry flag, the overflow flag. So when the destination is zero, this one is triggered, it becomes one. Then when you have a negative destination, the sign flag is triggered. And then when you've got out of range, the carry flag is triggered. Then when you have got the signed values being out of range, the overflow flag is triggered. So you must know how to write the codes for that. So maybe let me write an example of these flags, how they get triggered. Then we'll continue with this part. Know the data types, operators. You must know the offset, how it works. I already mentioned that this one is used to access what the address, and the PTR, the type, the length of, the size of. Yeah. So I think those are the important stuff that you must know. Let me just scroll. I wanna give you guys examples of this of this flag, how they get triggered. So I'm gonna start with the zero flag. So I'm just gonna write a short code. So the zero flag. Yeah. So we can say include. So this is the basic syntax. Again, you know, you have the data section. You are going to have the data section and the code section. So this is where you are going to write your code, and then you must say main procedure. So the function there, it's main, then the procedure, and then we close the what? The code. The main and main exit. Then here you must say main and procedure. So this P means and the procedure. So now I'm going to write our an example of how this is triggered. Suppose you have this EAX, we say we move 5, then we subtract EAX with 5. So the result is 0, then the 0 flag is going to be triggered, and will be 1. Then the carry flag, so let me start with the sign flag. Suppose I'm just going to edit on the same code, no? So that we don't remove this thing. So let's remove this. So I'm now coming to the sign flag. Let's say we move into EAX, we move 5, then subtract. So let me use an different color for this. Then subtract EAX with 5, with 10. So the result of EAX, we know that it is going to be negative 5 when you subtract it. So the carry flag is triggered, so it will be set to 1. So if it's not set to 1, it will be set to 0. So I'm sure you have seen this when you are running your codes. Then the overflow, I'm just going to add it here. into EAX 7FF. So let's say we're moving this hexadecimal number. You see that this is what? This is an 8 byte. Then we say add into EAX, we add with 1. So when you perform the addition of this, it will give us 0, 0. Remember, F plus 1 will be, we'll have 0, carry 1, 0, carry 1, 1. 7 plus 8 will be that. We will check this is out of bound. We're having 8 and 8 bits. So this is now a what? 80,000, 40,000, 1, 2, 3, 4, 5, 7. Also, this is still an 8 bit, and also this was an 8 bit. 2, 4. So, but this is a what? This is a signed positive, positive what? Number. So the overflow flag it becomes 1. So you must be able to give examples of this. Let me give you another one of how the overflow flag is triggered. I'm gonna ask you to write the code for this. So our result is assigned, it's a negative number. That's why this is now what is triggering the overflow flag. But this was a what? A positive number. So in a 32-bit representation, this one it represents negative 2147483648. You don't have to cram this, you just have to understand. So we're adding into a what? Into a positive number. Remember, this was a positive number. So we added 1, then we got that 80. This takes the decimal. Then this one, that one there, in a 32-bit representation is positive 2147483647. I don't have to write everything as long as you understand the idea. So let me give you another one. Trigger the overflow flag, another code that can trigger this. So just going to say example 2. Okay. This one will be, let's say we move into EAX, we move this and right. Yeah. So we're moving what? 80 million into what? EAX. Then we subtract EAX with 1. So if we do that, we're still going to get a what? A negative answer. Let's subtract the C. Let's try to subtract the C. What will be that? That will be we're subtracting with 1. So we can replace the rest with zeros to fill up with those bits. So you'll get 7F, F, 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 F. You see, ne? So this is still a what? A signed hexadecimal number. Still a signed hexadecimal number. So now moving to the carry flag. Suppose, suppose I come here and say move into EAX, I move 0. Then I subtract EAX with 1. So for the fact that we're gonna get a negative number, we know that EAX on this step it was going to be negative 1. Then we can say since we are going to be borrowing, it means that the carry flag is set to 1. Give you another example. The fact that there is going to be what? A borrow. A number in order to when you subtract uh, 0 with 1, finally you will have your what? Your EAX. It will be set to F, 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 A. As long as you are going to have a borrow, then the carry flag is set to what? Set to 1. So let's say we move into EAX, we move 10. So this is another example. And then we move 20. You will subtract EAX with 20. Okay? So also this, it will require a both. So we can say the carry flag is equal to 1. We're going to get negative 10. This in hexadecimal is going to be F, 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 8. So you check how you can get that. The sign flag is set when the result is what? Negative, negative. As long as you're getting a negative result. I think they've also explained this when in class and also wrote a code for this one. So I can now leave this. I'm now skipping to so this is another example of how the overflow flag is triggered. So this is out of range, hence we are going to have a what? Since we know that for signed integers is from 0 to 127, but this exceed, if you add 1, this will now exceed the range for what? For unsigned integers. Hence, the overflow flag is triggered. Same applies to this one. You add 1 into 7f, you'll get what? 0 kill 1. Yeah, you'll get this. So this exceeds the range. It exceeds the range. Hence, we're going to have our overflow flag being triggered. Then we've got this part. We have the offset operator, the type operator, and all that. So I think this, let me start with this one. The offset, it returns the distance in bytes. So that's what it do. Ne? So I think this will explain this well. Well, let me try to write it. Offset. So I said the offset is used to return the address. Let's just say it returns the address. And then the registers, they return the field at that particular address. So let's go back to that code. So this code here, it accesses the address of bval, and then offset wval is the address of that, then offset dval. So you see these are the addresses. So that's what it do. This, you see, if you see this on your code, these are addresses. Remember, I asked the question and you didn't answer when you saw this on your console. Then this is just the code that converts. So these are pointers. So we'll discuss that. I'm going to leave this, but this is very important also for the purpose of test one. And the PTR operator, it do what? It overrides the default type. It overrides the default type. Very important. Then here, if you check this code, my double is your variable dweight. This is just declaring the data type is dweight. Yeah, now we say move into AX, my double. So here we're going to have an error because the size, we will know that this what is a 16-bit what, but this is a what? It's a 32-bit, as it doesn't fit. And here we're saying move with PTR my double. So this will load since we are saying weight, you see, we are using the PTR operator together with the data type here. So we are saying move with PTR. My double. So now the data type has changed, and then we write that variable. So now this will fit because we have used the PTR operator. So that's what it do. It overrides the default type. So the default type is no longer the weight. It's now updated to weight. So this is now a 16-bit and a 16-bit. So it will load these two. Remember, this will be what? 8, 12, 16. Every byte it represent what? It represent four-bit allocation. So let me write it like this. Every value here on this array, remember this is an array. It represents four bits. So now when you add this, all of that four, you'll get 16. And we're using AX. Hence this, it will load that. Then this one, it will load the upper four. Because we say to move that into that. So this will now store 4, 3, 2, 1. Then we talked about the Little Indian order. We say this stores integers in memory locations. Then I said we group into 2, 2, 2, 2, 2, right? So, but you must be very careful as you group here, because you can because if it's numbers, if it's letters instead of numbers, you must add a zero. Suppose you're using A, B, C, D, then when you load here, you're going to say A0 like this. Because the assembler will rate this. If you are writing it like this, it won't read this as what? As numbers, right? So it must always read this as numbers. So let's see. So this is how these values or these integers will be stored. So we store them from the least significant to the most significant bit. Ne? Least significant, which is 78, to the most significant bit. So I hope now you know. And then this is just the address. So I said here you can even say 1000, 1001, anything. But the key part is how they are stored in the memory location. So this diagram here, it indicates how you will store this integer in a form of how it's stored in the memory location. For double width, it's everything. This is a what? This is a 32-bit. This is a 16-bit. And this gives us an 8-bit register. So every 8-bit, 8-bit. So actually store them like this if we're performing Little Indian order. So you must always read the question. It will actually guide you. Let's skip this for now. Then the type operator, it returns the size in bytes of a single element. So here we're saying move type variable 1 into EAX. Is the size in byte. Okay, so you see that for the first variable here, we're having byte, isn't it? The second one is weight, the third one is d weight, then this is q weight. So in a form of what? In bytes, type the size of a byte is 1 byte, né? Then the size of weight in bytes is what? Is 2 bytes. Then for d weight, the type the byte is 4 bytes. Then for q weight, the number of bytes is what? Is 8 bytes. Then the length of operator, it counts the number of elements in a single data. So if we look at this, so the length, we just get the length of your array. See here we have 1, 2, 3 elements. So that's 3. Then dup 30, 0, 0. So you just count 30 and those two, you get that. So if you check here on the code section, move into ECX the length of array 1, which is this one. So instead of saying move array 1, you move that there, because if you say move array 1, you were just going to get the actual number, which is okay. Here it is not initialized. Let's see, they did not initialize. So they're saying move EAX length of array 1. Array 1 is that. So the length of this array is 32. So we're using the length of operator. So the number of elements here is 32. So that's what it do. They could have also, let me give you another example here. They could have said move of array 2. You see that? Then you get what? 50. That's how you use the length of operate. Must also understand how you use the PTR operator. Just write the data type, then PTR, then whatever value. So this it updates the registers in a way that it will take a certain number of bits. It won't take everything unless if maybe you are saying deal with. You say here where it overrides. Remember, it overrides the default data type. That's what the PTR operator do. Now I'm moving. So this is just a code that will sum these elements. So having 3 elements, which if they added that, but we'll discuss. I'll try to write a. And also the pointers, I said they are part of your test. Pointers. So you must first understand how you write the syntax in assembly if you are dealing with pointers. Then we also have the jump conditions. So I'm going to skip these things and then I'll be writing the syntax so that you know what to or how to write these things. So you must look at nested loops and a general loop. Ne? Loop, you must also look at an array. You must also look at pointers. Yeah, if you guys can understand this and also how to reverse an array, you have done your part. Page. Okay. Let's start with the syntax of writing a general array in assembly. Include IBM32 in the data section. You're going to have your variable and your data type. Yeah? Then here you have your value. Then the dot code section, prog. So we can say move ESI into ESI. We usually use the ESI for accessing the address of the particular variables. So let's say it's 102030. Let's say offset X. Then I can move into maybe EX. We have two, but yeah, we can move the address into another register. But let me not write this. So I just wanted you guys to see how you declare an array, right? So this is how you declare an array. The variable, the data type, and then those values there. Then here you can say call int. These are dealing with an integer. So there's a procedure. You must know it. So I'm going to write them here. Call crlf. Then also call them right. So this is for displaying the content of your registers. Then you exit main and p and main. So this is how you write a simple code for. So I want us to do the one whereby you reverse an array. So yes, just reverse 1, 2, 3. Data section, we are going to declare our array. Let's say 1, 2, 3. Then allow me to move main log. We can move into EAX to move the first value. We store it in EAX again. Then we say move into EBX, the next one. So EBX is now holding the content of. When you say +2, if we're using the data type, I should have said should have said the data type here. Here with, yeah. Remember, it's the array name, which is X in our case, and then the data type, and then that. Then now it means EBX is storing. Remember, if we're using the way this is 048, it means EBX is storing 3. And then move EBX we move EBX to X, it means that now we're starting with what? We're starting with 3. Then move I should have returned this like this and say that I'm writing things which I'm going to keep it like this, right? I'm going to say on the data section, we declare our array 1, 2, and 3. Then go to the code section. So we can say move into EAX. We move what? If I say move X, it means that EAX is storing what? EAX is storing the first value, which is 1. Right? And then I can say move X plus 8. It means EBX is storing 3. I'm still writing the same thing. That time I wrote array here. So it should be X. That our array name is X. Then we move. If I move EBX into X, it means that now the first value is now updated to 3. So we're now actually having 3, 1, 3, 1, 2. Isn't it? We're having this. So we're moving this there. So this will be 3, 3, 2, 1 actually. 3, 2, 1. 3, 2, 1. And we can say move. If I say move, I move EAX, which is 1, right? We're storing it in the last position. So here we're having on this step we're not having 3, 2, 1, but we're having 3, 3, 1, 3, 1, 2. Let me see if this makes sense. 3, 1, 2. So move the EAX into X plus 8. It means now this updates to 3, 2, 1. Yeah. So I'm not sure. You guys, you should try to follow this order and see if you can also do it. So at the end, we have 1, 2, 3 being reversed to 3, 2, 1. So now the syntax of a general loop, ne? In assembly. So you can say move ECX. So if you want to decrement, you're going to write the number. If you want to decrement 10 times, you'll write 10 there. Then this is your label L1, loop L1. So that's where the code ends. Just to do an example of this. Let's say I want to print 1 up to 5, ne? So we can say 1, 2, 3. 4, 5. Yeah, suppose we have this, and I want to print this thing. I want to print 1, 2, 3, 4, 5. Using this syntax. Means here I can come and say dot code. Okay, let's move into a ESI, the address of those values. Remember, this is the address, the register for counting. So the ECX is the counter register. Then you can say 5. So if you don't want to say 5, you can say length of y. So it's the offset, the length of operate. This must be stacked together, and then you say 1. Then you can say L1 move into EAX ESI. Let's say we're moving into EAX, the register, the address of our array. Then you can say call write deck. This is another procedure that you must know what it do. Call CRLF for going into a new line, and then add ESI. And if I say type Y, so this is the type operator. It's also used to do what, to update the size of your data type. So, but here everything is fine if I write it like this. Then you say loop L1. But if here I was to write another register which is not a 16 and a 32-bit, remember this is a 32, then we're going to have an error. If I was to update this to that AX, so it should be ESI. If I'm using the type operate, then loop L1. So we have created a label, our loop, then we close it. So remember, that's the syntax of creating a loop. Then you can say exit. At the end, this will print 1, 2, 3, 4, 5. It will print that. So basically, chapter 4, 5, guys, and 6. As long as you are doing the coding part, I think you are doing justice to yourself, because on chapter, check something here. This chapter 5. So chapter 5 is based on using the conditional loop. So you must know what this means. The jump if greater, jump if not less than or equal to, jump if greater or equal to, jump if not less, jump if less, jump if not greater than or equal to. So let me add those short mnemonics that you must know, because they're gonna ask you to mention the procedures, to mention them. Even if they don't ask you to mention them, you should know how to use them. We've get max xy, we've got get second, go toxi, random 82. Obviously, this for generating 32 bits integers from 0 to FFFH. Then we've got the randomize procedure of the read deck. There I was using the right deck. So this one is for if you want to print the content of your registers in what in decimal format. Then this one right hex is for in hexadecimal format. Have the string length. It returns the what the length of a string. It explains itself, right? An example, if you have this weight, it has got 4. So it was the console was going to return 4. So I'm going to have this one weight message. This one is for displaying the message. Wait for a key to be pressed. So yeah, you should practice how to use this. Then the random range. This one it generates what? The range of certain integers. So I can have a lot of them, so I'm not gonna write all of them. Yeah, the common ones, you have the close file, you have the clear screen, you have the create output file, you have the CRLF, you have the delay, you have the dump mem, the dump rex. This one is common, and this one and that one, right? And also this one, if you have the close file, this one is for closing a disk file that was recently opened. So use search and see for what happens. But the most important thing is to understand why you are using them. So you can't just write anything. So the syntax of pointers people in assembly. You must practice how you declare and all that. Here I'm just going to write the syntax only, and then we will see when we are doing the coding part how can I implement the pointers together with the loops. Say loop but the key thing, so yeah, I'm just giving you guys an example. Good main clock. Suppose we move offset. So this, the offset is the address of the what of this number. So I use the offset. So I'm trying to access the address there. But if now I say move into EAX, and then I use the square bracket. So this is for getting the actual V at that address. Then I can call write int. Then I can also call CRLF. This is not necessary. It's just for writing your numbers in descending order, right? Going down, not in descending order, but in this format. Not in this format, not the vertical format. So we close main and P. I don't want to get the syntax wrong. Hence, I'm writing this again and again. So if we were dealing with an array with pointers, I think I'm gonna end here. Array of pointers. Using the array. So suppose on the data section you declare your array. Put so same thing here. We're storing the address of those numbers into ESI. So now that I'm saying offset W, ESI is pointing to the first element, the first element. And then we can say move EAX. So if I say move EAX and then I use the pointer, this the square brackets, it means I'm trying to get what EAX will store the first value, which is 1. Then if I add into ESI with 4, we're saying move the pointer to the what to the next value, which is 2. Then if I say move EAX now on this step, if I say move EAX into EAX, we move ESI, it will be updated to EAX will now be updated to 2 because we did say add there. Then if we exit, so at the end, your content on your console, you should have EAX being equal to 2. So this requires practice. So I'm going to stop the recording here.